Alright, time for another draftphysics.com video presentation. Debatephysics.com also. But it doesn't, like I said, the debate isn't in any coherent form. I can't find anybody to participate in some sort of reasonable argument, counter-argument way. And so we're stuck with it being less than as productive as it could be. So these videos have to go on for years instead of just days. And I suppose some of that is unavoidable because it's all learning curve, because science really hasn't studied any of this stuff to do with kinetic energy and motion in the universe and momentum. Physics hasn't paid much attention because it has all kinds of dualities, all kinds of conflicts in their statement. So, as I have repeatedly pointed out, it does not take 25 times the fuel, to move something 5 times as fast. So 5 times the velocity does not require 25 times the fuel. It just requires 5. So if you want to make a drill go 5 times as fast, you'll use 5 times the electricity, maybe a little less even. Same thing with cars. Doesn't take 25 times the gasoline, to go from 10 miles an hour to 50 miles an hour. You won't be using 25 times the gas. It's just a fact. And you'll only be using probably 4 times the gas or 3 times, because the car actually gets more efficient in some respects at the higher velocities. So, big, huge flaw. It doesn't work. So the current bar video is basically, he's making the statement that this is real, that this idea that energy equals mgh, that is how high you put something in gravity determines how much energy it has directly. That is, the height is completely equal to the idea of velocity. The proportional is almost a direct equality. So obviously I would be saying that it's, the gravitational constant times the mass tells you all you need to do, in the sense of it's just a matter of how much time are you in the gravity. So I have illustrated this so many times, we'll just do it one more time, just because this is, it just for clarity. It's, the argument is if I drop something 1 unit of height, like rolling things also, 1 velocity, I get, yes, it has 1 velocity. And if I drop it from 4 units of height, it's only going to have twice the velocity. And the reasoning simply is that obviously it's going to be going half its speed right here. This 1 unit of time is going to be the same as this unit of time because it gained velocity. So its velocity is increasing. It's falling through the gravity quicker. That is, it's moving a lot more in the same unit of time. And it's time that decides it's 9.8 meters per second. So you got your 9.8 meters here, and you get 9.8 meters of velocity here. Now you only travel 4.9, so it's 4.9, 4.9, 4.9, 4.9. But the fact is that after you fall 4 times the distance, you'll only have used 2 seconds of time. If it was 1 second for 1 velocity, you've only doubled the time you were in the gravity. So how could I have 4 times the energy? How can I have 4 units of energy when we know once I was going 9.8, well, the 9.8 is right here. I got that for free. So once it's going 9.8 here, no force has to act on it for it to go 9.8 meters. And so all it's getting in the second unit of time is this. This is the only bit that's new. So you got 1 unit of distance, 1 unit of, effect of acceleration. And the rest of it's coasting on your velocity. And it's completely understandable that that's true. And so you're going twice the velocity when you hit the ground, not 4 times the velocity. You only have twice the energy because you only went into gravity twice as long. You only collected twice the force. And as Newton said, 1 unit of force, 1 unit of velocity, 2 units of force, 2 units of velocity, 3 units of force, 3 units of velocity. Completely proportional. All right, so getting to Hooke's law. So they've now perverted that into The consequence being these are essentially weights hitting the ground, and they're claiming that something with, you know, twice the real weight really is got 4 times the energy. So this is their new argument. So besides this, defending this absolute crap that everybody knows is wrong, I mean, nobody can really believe it takes 25 times the fuel to move something 5 times as fast. It's just idiotic. I think it's no way they can't live on planet Earth and experience machines or devices and think it really works that way. It doesn't work that way ever. Nothing. Turbines, windmills, all these things does not work this way. They make windmills bigger and bigger and bigger. The velocity is slower and slower and slower. Because it works, okay? Slower isn't a bad thing. Heavy things moving slow is just as good as fast things moving, light things moving fast. Anyway, so yes, just no evidence of this being real anywhere in reality. And the fact is, there are some experiments that kind of decisively prove it don't happen, ballistic pendulums, crash tests, blah, blah, blah. But they just couldn't care less about any of that. So what they're saying now, again, it's just so Hooke's law basically says, look, you put 1 unit of mass on, you get 1 unit of compression in a spring. You put 2 units of mass on, you get 2 units of compression. Okay, perfectly proportional. So that's Hooke's law. And what they're saying is, no, 1 mass unit, you put 1 mass unit on, you get 1 unit of force, 1 unit of energy. And then you do exactly the same action and put a second object the same exact mass on and double the mass, you now have 4 units of energy. So somehow doing exactly the same thing here has 3 units of force, and doing it this first time only was 1 unit of force. So somehow doing it the same exact action produces 3 times the energy. And it's not possible for it to do that. That's free energy. That's crazy. So that's their assertion, though. They're saying that twice the spring compression, twice the weight, is 4 times the energy. And obviously it's not. So so I'll describe his most recent experiment, which, you know, they get better and better in terms of he improves them, they're stylish and all that kind of crap. But it's just absolutely wrong, you know, and it's, you know, I'm just saying that what they're defending can't be defended. So you know that there must be something in the experiment that is flawed, because the underlying the statement they're making. So he's overtly stated it in the title that MGH is real, that it has something to do with actually calculating real energy, that it matters how far you travel in gravity, not how fast you travel in gravity. And I've explained how meteors, a ton of things demonstrate this isn't true, that this has nothing to do with the subject, that you can go through gravity very fast. So if I was a gravitational mass over here, a planet, and I was going to fly a satellite by, we already know that the faster I fly the satellite by, the less exposure to the gravity it has, the less time it's in the gravity, and the less it'll be bent. And the slower I move it, the more it's going to get bent, because the more time the gravity will have to act on it. Thin ice, you know, you can slide across thin ice. Why? Because you can change how much gravity you're collecting per the distance you're traveling on the surface. So the weight you're putting on the surface goes down as you go across the surface faster. I mean, these are such elemental statements. And, you know, instead of attempting to defend how any of that crap could be true, and that there's some other experiments out there that demonstrate that to be true, they just contrive crappy experiments. These Chardonnay frauds, essentially. So we're going all the way back to 1720 and saying, let's try to fool physicists. And again, it's doable because people want to believe this crap for whatever reason. Like I said, I still can't figure out why people want wooey physics, but whatever. why scientifically minded people want crap to be true. I mean, stuff that just doesn't make any sense. You know, it's almost like going back to the Darwin days, and you had the guy who was arguing that giraffe necks got longer because giraffes wanted to have a longer neck. You know, kind of a silly theory. Yeah. Evolution doesn't work that way. So, I guess we'll pop this up real quick. So he did a video using foam. So completely identically duplicating the de Châtelet bullshit experiment that I've outlined so many times. And I thought it was a gimmick. I mean, I thought he was going to come up with another video where he does it more ethically. You know, in the sense that shows that it doesn't matter what shape the object is, that somehow he could make flat surfaces also do the same thing that the round surface was doing. So I might as well illustrate that again. But anyway, that's what I thought. And no, I was wrong. He was just doing the same fake experiment that I've already pointed out why the reasoning was bad, that smart people should have figured out you can't measure energy that way. It cheats. Okay. It's got an obvious cheat built in. As obvious as somebody trying to fool you by pointing the arrow. You know, having an arrow with a point on it and then an arrow with a flat surface. And they shoot it into something, and the one with the point goes in deeper. And then they say, see, that arrow has more energy. Now, you know that wouldn't fool you. Okay. But you're trying to sell exactly the same kind of fraud. So it's just that you have to be a little tiny bit more sophisticated to see this fraud. So that's where this started, because then he started doing this dropping round thing. And so, you know, okay, I complained, but, you know, and some part of you says, well, how much difference can it make in these other circumstances? Well, of course, it can make a difference. And there has to be a reason. 1 pound, okay, put on a scale is 1 unit of energy. Another pound put on the scale is 1 unit of energy. Those two actions cannot equal 4 units of energy. I know that's absolutely true. So there's no hope this experiment that you're doing is correct, because I know what you're saying it proves can't be right. It's idiotic. So we know there has to be a glitch in your experiment. All right, so now, you know, the simple truth is I wanted to see, okay, him do the experiment correctly. So the foam idea is kind of nice because it's easier to extract something out of foam than it is clay. Clay is sticky. So if you can get the foam to be proportional, that is obey Hooke's law, it might have some use. I don't know. You know, no one's tested this stuff. All right, so the idea of the de Châtelet experiments were, probably should just draw that down here, is that you have a clay surface, and what you're going to do is drop 2 objects, one at twice the velocity presumably of the other one. Okay, so a 2v and a 1v, and they're the same size and the same shape, but they're round spheres. That's the trick. And so you drop them, and the one with twice the velocity, if you measure the displacement, that is how much space was created, okay, displacement in the clay, it ends up being 4 times. Now, this is sort of like the rolling arguments, lots of other arguments you can make. But the clear reasoning is that the round surface is the cause of that. Because, if you put in a surface that was just a cylinder that's flat at the bottom, both experiments will have to do the same thing, because the surface that's penetrating doesn't change. But clearly, as you drop a round surface, the shape of the object changes as you go deeper. So the deeper you go, right, when you're going barely hitting the clay with the surface, all the energy is down and very little energy is sideways. And as it goes deeper, there's more and more of the surface is sideways and less is going down. So the proportion of energy pushing, force pushing clay sideways versus the proportion pushed down is changing to a peak value once you go into the clay. So the trick was they didn't go into the clay deep, because then it doesn't matter anymore, because then they're both subjected to the same amount of that round surface. But the fact is the one with twice the velocity was doing more of this surface, and the one with one velocity is doing more of this. So one was pushing down, one's pushing sideways. That's the advantage. That's why the higher velocity was able to go proportionally deeper. Disproportionately deeper is displace more clay. Is because essentially the shape is changing. So you're going from, say, a flat arrow to a pointy arrow in the process of pushing through the clay. As you go deeper and deeper, the shape of the object is essentially changing. And so you're changing, the constant. You could say this is like the spring constant or something else, and it's being changed as you're doing the experiment, in a way. And that's the entire reason for the outcome. And if they would have dropped square bottomed things, Brozo actually did that experiment and didn't find, that the results were rather dramatically different. He didn't find them to be 2 to 1, but he found them way short of 4 to 1. So clearly it makes a difference. Okay, it's not fake news. It's a real problem in doing these experiments. So now he's dropping round things on rubber bands. Okay, so he has 2 rubber bands, drops the round thing on the rubber band. And yeah, okay. At first glance, I didn't see any, can't matter much, but the same thing is really happening. The faster the surface hits the rubber bands, the more it's going to stick to the surface with friction. So there's going to be a place where there's a lot of friction, okay, right here, where the rubber band is hitting the round surface. So you have this kind of a giant fulcrum, you could describe it as. And what you really want to do when you're going to test something with a, say you have this as a rubber band here and you're going to test it, you really want to have a tiny point, okay, for doing your experiment. So you have your mass and you're going to just hit the rubber band and compress it. You don't want to have the surface touching a lot of the rubber band, because then the rubber band has to slide across that surface and stretch across that surface. And who knows what kinds of energy losses you'll have depending on how much stretching there is of that surface. So you're going to create all kinds of points where you can lose the energy to heat and friction and sliding and all kinds of, rubber meet the road kind of problems. So I didn't think of it at first sight, but I should have, because I did complain as soon as he started using round objects. I'm saying, why are we using round objects? Don't we know that that's a liability? And and it really does matter, because it's physics. Now the other problem is his experiment has the rubber bands, their thickness part is this way. So there's 2 rails of rubber band with their thickness this way, and the object comes down this way. So obviously the rubber bands have to flip. And that's another problem, because it's going to flip and stick. And so obviously velocity could have a lot to do with how much the rubber band stretches before it flips, and how much it doesn't stretch before it flips and sticks. And so you're basically the argument is you're basically changing the spring constant of the rubber band. So I guess I could draw that. It should be back. Okay, so the idea is there's, you could stretch a rubber band by having a tiny thing there. And then you can stretch a rubber band. Let's just put this curved surface here, and then the rubber band goes straight. So you can understand that the part of the rubber band that's stretching here, okay, that's freely stretching in the air, no rubbing friction, would be this length of rubber band. And in this case, okay, because of the contact with the surface being huge, there's only this much rubber band doing the stretching. So in a sense, you're that's changed the spring constant of the rubber band, because in a sense you've shortened the rubber band. You've taken some portion of the rubber band out of the stretching game because it's stuck on the surface. And so the spring constant in this case is constantly changing as, it makes first contact. It's a little bit of rubber band stuck, and then it's more rubber band stuck, and then more rubber band stuck. So obviously the further down it goes, the higher the velocity, the more rubber band taken out of the stretching game, and so your K value, if you were to use a spring constant, is obviously changing as the experiment's happening. And so that is why you got what I consider to be just idiotic results. Can't happen in this reality. 2 pounds can't be 4 pounds. Okay, 2 pounds can't be 4 units of energy. If 1 pound is 1 unit, 2 pounds has to be 2 units. 3 pounds has to be 3 pounds, 3 units of energy. There's no way to get around that. So, no logical way to get around it. All right, so I'll make my what I think are kind of direct accusations again about the character of these people, and the fact is we know they're frauds. So, Brozo, a month ago now, promised he was going to redo his lever experiment that everybody was talking about, and that he was responsible for causing confusion, and so he has to fix all the confusion he caused, and by doing the experiment again, much better. And nothing. Just nothing. No evidence that he's going to do it. No evidence that he hasn't done it, and the fact is he can't break it. He can't fuck the experiment up enough to cause that 1.4 thing to happen, to cause a half mass to be twice as difficult to move as a full mass. That is, you need 4 times the energy to move a half mass, twice the velocity. When no, all you need is the same amount, twice as much energy. All you need is the same amount of energy. A half mass can go twice the velocity because it's only creating the same momentum. And momentum does run the universe. All right, so, and then we have the Dispar case. So he did do the floral foam denting the surface. And again, that's a key point, is denting the surface with objects falling. Now, I would argue that I'm certain he tried it with, instead of the round wooden balls, he did it with the little metal things that he was using before. He chose those. So the little metal sockets, I think they were. So they have a flat bottom. Now you see those in the newest experiment because he uses them to add weight. And apparently their weight is exactly the same as the wooden ball. So, what's the reasoning here? There's none that makes any excuses. So I'm sure he did penetrate the clay with the flat surfaced objects. And I'm sure he saw that he didn't get the same results as with the round surface. Just an absolute fact. And that the results were more in line with my predictions than his predictions. Now I'm just making the accusation that there really isn't any reasonable alternative here, is there? All of a sudden he decides to use round wooden balls. Why? And when you're doing the very experiment I've talked about for 2 years, 3 years now, 4 years now, the Chardelais fraud experiment, why would you duplicate that? When I've already made the clear accusation that it's a fake, fraud, and phony experiment. So, the fact is, I think he did do the experiment. We didn't show that to us because he's a liar and a perverter of the truth, a propagandist. It's not about proving the truth or establishing the truth in any kind of honest way. It's just about contriving experiments that produce the results he thinks. I don't even know what he thinks. I don't think he's smart enough to understand the physics, so I don't think he has a physics point of view. He's just trying to prove me wrong. And so to do that, he has to prove them right. And obviously them never did any of these experiments with any kind of proper scrutiny our technical equipment. And so he's just taking advantage of that to deceive people. And I just think it's kind of obvious that I think he did drop the metal things into the foam and he found the results aren't the same, and just verifies my point that all of these experiments have these variables in them, and you've got to account for them. All right, so does anything else need to be said? Like I said, he did improve the experiment. I mean, I did fix parts of it. You could read the scale this time. It's nice and pretty. The camera's close enough where the parallax doesn't matter in terms of the distortion. You can actually read frame rates. Now, I would argue that in the video he did, the thing that's supposed to be moving 1 velocity, was moving a little less than that. So the ratio was like 5 to 12 instead of being 5 to 10. But it certainly wasn't enough of a defect to cause the plainly, completely erroneous results he produced in the experiment, in the sense of giving us the impression that something with twice the momentum has 4 times the energy, which it can't have, and vice versa. Anyway, so I don't know if there's anything else I need to say. Yeah, I'll think on it. I mean, there's lots of ways to look. I'm not going to keep saying, look, do the experiment this way, do the experiment this way. I'm just saying it's not ideal to have rubber bands like this that flip this way. So it'd probably be better if you figure out, you can run a bar going this way on both sides, and then you can have the rubber band go across, have 2 rubber bands, I guess, in this case, on either side of the pole, and then drop something. And it might be better than the current configuration where the rubber band has to twist, which probably isn't ideal at all, and frankly. Yeah, I'm still not a huge fan of the pole going through a hole that and then the ball falls, because the problem is any time it turns as it's pushing down, there's also friction points, and it's hard to know. Heavy masses, obviously twisting will cause more friction than lighter things twisting, so it's really hard to say. But whatever. I mean, these are all experiments that could be done better and better. But the point is they really don't looking for those. They don't do the modifications that create anything that makes any indication that their previous experiment might have a defect in it. So they're never going to publish the experiments that don't come out their way. Like Gosling, 2 years ago, he did a clay experiment, and the results didn't come out the way he wanted them to, and he didn't show the experiment. He just said, they didn't come out our way. What do you think went wrong? Because that's part of their game, is not to show that it doesn't work. Just tell us it didn't work. But anyway, I think that's probably enough of a video, but we'll see. Alright, so finishing up. So in free fall, that is when something is not in contact with some other object that will share its condition and transfer its motion or energy. MGT is what defines how much time it's in gravity. So if something's being affected by a force, photons, doesn't matter what it is, it's going to be affected based on how long it's exposed to the force. So it's like a spray can of paint. I can spray the spray can of paint. It shoots out in a cone. It's sort of basically producing the inverse square law. And the fact is, the faster I move something through the paint, the less paint will get on the surface. And the slower I move it through the paint, the more paint will get on the surface. And it really has how far the surface is, how much time, how much distance it's being exposed through, makes no difference. And in this case, you're going with the flow of the paint. And in the case of going again, you go against the flow of the paint or with the flow of the paint. The paint's moving the speed of light, so let's understand, your speed is going to be quite irrelevant. And it's just about how much time you're exposed to the spray, how much time it pushes you, and that's it. And so, yeah, it's a cornerstone of physics. It's absolutely nonsense. We have no empirical evidence, nothing real to show that the height determines, when the fact is the height is determining how much time, and it's the time that matters. And it's just a fact. And yeah, so you get a wrong answer. MGH produces wrong answers. MGT in free fall produces correct answers. Again, if you tie a string to something and cause it to fall less quickly, that's a whole different equation, because again, it's time, but now it's going to be much more time. It's not free falling. So you're in the force a much longer time. You're going to collect a lot more energy. So anyway, all right. So yeah, it should be a proof for everybody, is the fact that I can let something fall the same distance and produce varying amounts of energy traveling that same difference. If I allow it to, just as you know, lifting, if I lift something very slowly, I'm going to do a lot more work than if I lift it quickly. And the same is true for dropping things at a decelerated or a less than free fall speed. That the longer you're fighting the gravity or being exposed to the gravity, the more you'll be pushed by it. And less amount of time, the less amount of force. It's just, it's 1/2 mv squared and mgh are just wrong formulations. They have nothing to do with reality. They just get wrong answers. And physics hasn't had the courage to actually demonstrate or prove them right. And that's why I can make this accusation, is because you can't produce any evidence countering it, any good evidence. Because there isn't any. Just a fact.